Trigger.dev is great for running durable, reliable tasks. But to trigger those tasks from a webhook, you need to make an HTTP API call. That means you need something to receive the webhook, verify the signature, transform the payload into the shape that the Trigger.dev API expects, and then send it on. That's where the Hookdeck Event Gateway comes in. The Event Gateway can act as a lightweight, serverless webhook ingestion layer. It receives the event, verifies it came from where it's supposed to, transforms the payload to match what Trigger.dev expects, and delivers it to your task's trigger URL. And you get observability, retries, and replay on every event for free.
So how does it work? An event happens on GitHub. That triggers a webhook post request that hits a source in the Hookdeck Event Gateway, in this case called GitHub. It travels along a connection. As the event travels along that connection, a transformation is applied to it to wrap the payload of the webhook actually onto a payload property. That's the structure that the Trigger.dev API requires. A request is then made to the Trigger.dev API, here represented by Trigger.dev made. The request is authenticated using the API key that's configured within the Hookdeck Event Gateway. Here we've got it represented as a bearer token. In this case, the request is made to a router, GitHub Webhook Handler. It looks at the event type, and depending on that event type, if it's a pull request, it'll pass it to the handle PR task to run. If it's an issue, it'll send it to the handle issue task to run. And if it's a push, we'll send it to the handle push task to be run.
Okay, so let's see some of those pipelines in action. So what this script does, it creates a new branch locally, actually adds an empty commit, and then pushes it to GitHub. So what we'll see over in GitHub is we have a new demo branch, which, as I said, it's an empty commit. So what we'll see there is, now if you go into Hookdeck and we look at our events, let me click on this, you'll see this was 4:53 and 17 seconds, which is just a moment ago. It's created this attempt. So that's actually delivering it to Trigger.dev. But before we go into that, let's have a quick look at the flow. So we've got a few connections set up, but this is the one that's running at the minute. These other ones are paused. Within here, we've got a transformation. Within the transformation, we manipulate the content and put the content onto a property called payload. Because we are making an API request to the Trigger.dev API, we don't have header information, so we instead embed the important event type within the payload itself, and this is what's required in Trigger.dev. Now, as we said, if we go back over to our events and this view, we've got this request that's gone out with the payload property, the event of type push, response back. It was accepted by Trigger.dev. We can see there's a run ID. Now, if we go into Trigger.dev, we can see our tasks listed here. This is the handler. So here in our runs, we can see the handler was first called at around that time again. That then triggered the child task to handle a push, summarize the content, and then sent a message to Slack. You can see all that happened in 3.3 seconds. If I go into Slack, see down here at 4:53, we got a notification that was a push and there was an empty commit. That's correct. Now, if we go back into GitHub, we'll create a pull request. There obviously isn't any content. There's no point in me typing anything in here. I'll create that pull request. Now that will trigger a webhook. Again, if we go back over here, we'll see this is just now. Again, it's triggered a request. This time we've wrapped the payload and this is a pull request. Go into Trigger.dev, look at our runs. First one, we've got the handler, the task router, effectively. Then we've got the handle PR. This is having a look at what's changed, so nothing's changed, but we still post a review. So this is the part that actually uses Claude or the Anthropic API. And then if we go into GitHub and look at our pull requests. Here's the new demo with the empty commit. And we've got an AI generated summary. This appears to be an empty commit, no code changes. Obviously, if there is content in here, it's much more interesting. It can provide you with actually valuable feedback. The last thing to look at is issues. Let's create a new issue. Not a great report. But again, this will trigger a webhook. This new webhook's come in. So there's a new issue that's been opened. In fact, we've got a few more that's come in actually. Actually, what we'll see here is we've got an issue labeled. So this is coming afterwards. But first, let's go into trigger.dev. Let's look at the runs. We've got the webhook handler. There was an issue created. It triggered this child task. Child task handled issue and applied a label. And it said bug and a question. Question mark, we've said there's a bug. So that's the 3 different scenarios in action. Before we conclude, I want to talk about a slightly different setup. You may remember we covered this pipeline setup where we have GitHub, we have a single connection in Hookdeck, we have a task router, task within trigger.dev, and then multiple child tasks. Now, there's another way of handling routing and handling the routing in Hookdeck instead. And in this other approach, you instead have 3 different connections. And those 3 different connections use filters to ensure that only events of certain types are handled by those connections. And then you call the specific task within trigger.dev and you remove the need for the routing task in trigger.dev. Pros and cons to each approach, but I wanted to highlight that this is another architectural approach. You'll see that that's what this looks like in Hookdeck. We've got, at the minute, we've only got this main handle active, but instead we can have 3 different connections, basically 3 different routes, and then we can have filters set up that ensure that on this GitHub to handle PR connection, only pull requests get through. So that's another approach you can take. So in this walkthrough, you've seen that the Hookdeck Event Gateway handles the webhook edge, verification, transformation, retries, observability, and trigger.dev handles durable task execution. Together, you get a production-grade GitHub agent automation pipeline without standing up any extra infrastructure.